Hello, everyone. My name is Lev Looney, and today I'll be talking about hurricanes, the basics, and getting into some forecasting. But before I get started, I want to give an introduction about who I am and how I kind of got to where I am. So, like I said, my name is Lev, but I grew up in Virginia, along the coast of Virginia, where I grew up water skiing and surfing, and fell in love with studying the ocean and the weather in order to find where the smoothest lake's going to be or where the biggest wave's going to be. So when I found out you could actually study the ocean and make that a career, I jumped right onto it. So I went to college at the University of South Carolina, where I did my undergraduate and was really fortunate to get involved in some research. And so pictured here are some of the images from different research opportunities. Starting from the right, I was in charge of maintaining the aquariums for the university. And so this is just a picture that I took when I was mixing up some chemicals with some seaweed algae. Second from the right here with the boat, this was an internship I had in Virginia, but I had a really cool day. We set up an experiment that just sucked up water off the side of the boat and did some tests on it. So we drove up and down the river all day, and that was my job. This third picture in the marsh, this is in the marsh in South Carolina, knee deep in the mud, looking at how snails move with the tides. Here on the left, this picture with all the blue, that is at a naval weapons base in New Jersey. We were looking at the properties of sound and how oil spills influence them. Here in the top left was presenting my research. I was really fortunate to travel all over the world to get to present. And so one of the other themes I want to talk about too, besides hurricanes, is also how fun it is to be a scientist. But where am I now? So I'm at the University of Miami, where I'm doing my doctorate or my PhD in meteorology and physical oceanography, which is just a fancy way of saying I study how the ocean and the weather interact. It's funded by NOAA, the National Oceanic and Atmospheric Administration, their Atlantic Oceanographic and Meteorological Laboratory. One of the cool things about graduate school and studying science is if you do research, you usually get it funded. So I actually get paid to go to school, which I know what a lot of you all are thinking right now. If you woke up every morning and got paid to go to school, in addition to having fun and learning and seeing people, you'd be a little more excited. This picture on the right is me in the blue, and the white are my two colleagues, and in the back are all our bosses. Another fun thing about studying the ocean is you're usually by the ocean. So right now I'm actually in this building over here on the left, where I just came from lunch, but I actually ate lunch right on the water. I sat there and watched for manatees and stingrays, but usually when you study the ocean, you get to stay near the ocean, which is really nice. I mean, who can complain with an office with a view like that? But there's a lot of cool opportunities in oceanography. So here's just a bunch of different pictures. On the top right, the University of Miami has a shark tagging group. So this is a giant hammerhead shark off the coast of the Bahamas they're tagging. Here in the bottom right is a friend of mine, Allison, who I think has one of the coolest jobs. She looks at coral reefs and how climate change is impacting them. So she spends her days scuba diving off the Florida Keys. Who wouldn't want to do that for their job? And then, in the middle on the bottom is a group at Miami that looks at the science behind farming fish. So if you like to eat seafood, I love to eat seafood. There's science behind farming fish, and Miami does that. And here's a bunch of other pictures from going on the boats and collecting data and then sampling that data. But to today's topic, hurricanes. So this is an awesome picture from Hurricane Isaac from outer space. And you can just see how massive of a storm this is. But why do we really care about hurricanes to begin with? That's because they can cause a lot of damage. If we just take one storm, for example, something that happened fairly recently, Major Hurricane Ida, August 29th to September 1st in 2021, is a Category 4 storm that made landfall on the coast of Louisiana. As you can see here in the bottom right, this massive storm, right? You can see it goes all the way from Texas to well into Florida. It caused $75 billion in damages. It had winds of 150 miles an hour when it made landfall. Made landfall in Grand Isle, where you unfortunately saw a bunch of images that look like this. Total devastation, a lot of destruction. Well, it wasn't just where it made landfall. In areas outside New Orleans, outside the levees, you see a ton of flooding, where this is a street, but they're on a boat. And even all the way in Pennsylvania, where people like you were going to school on their school bus and they got stuck in a flooded road from a storm that was due to Ida, and they had to be rescued from the back of a school bus. Or New York City, where we saw that the subways got flooded, and here is just an underpass that was completely underwater. In fact, from 1980 to 2021, the US had 56 tropical cyclone billion-dollar disasters, totaling over $1.15 trillion. If you look at all the billion-dollar disasters, tropical cyclones were 53% of those. In addition, these 56 storms caused almost 6,700 deaths. So they're clearly very important. But what does a hurricane really look like? So it's this big spinning storm. So on the surface, you have really strong in the northern hemisphere counterclockwise rotation. But right in the middle, you have falling air, which means it's usually pretty clear, and we call this the eye. Right outside the eye, you have the strongest winds called the eye wall. You have rising air, so it's usually pretty heavy rain. And then you have these alternating patterns of rising and falling motion. Where it's rising, you usually have rain. So this leads to rain bands. And hurricanes get their energy from the ocean. This is from heat released at the ocean surface. And I like to say this is my favorite slide. Why? This is what my PhD focuses on. So I look at specifically how hurricanes get their energy from the ocean and kind of what influences how much energy they get. But that's a really important fact. Because of that, you need warm water. So hurricanes really happen over the water near the tropics. You kind of see there's this gap right along the equator, and that's just due to this weird force due to the spinning of Earth where you don't have a change in that rate of spin. It's really complicated, but just know that it's called Coriolis, but it doesn't really exist right at the equator. And so there's not enough spin to create these storms. But you see they exist all over the world. They have different names based on where they are. They are all tropical cyclones, but when they're strong enough and they're near the US, we call them hurricanes. When they're strong enough and they're near Asia, they're called typhoons. And in the southern hemisphere, we just call them cyclones. Here in the US, we base the strength on the sustained wind. When it's pretty weak, we call it a tropical depression. When it gets a little stronger, it's a tropical storm. And when it gets stronger than that, we call it a hurricane, with categories 1 through 5, and 5 being the strongest hurricane. So when do they happen? They need that warm water. So they happen at the end of summer when the water is the warmest. In fact, hurricane season is June 1st to November 30th. But really looking at this graph, and this shows the number of storms per each date, we see that it really peaks, August into October is really the peak of season. Peak being mid-September. That's when it's really busy. Where do they really exist in the US? So what these next couple of slides will show is the climatology per month. So for this slide, it, for example, shows June. And so where you see blue is if a storm is going to form, this is where it's likely going to be. And green's where it's more likely. And what you'll see in the future slides is some orange, which is the most likely. So in June, there's just not enough warm water. But in July, still not a ton of warm water. There's not that many storms. Come August, it really peaks up. And for people in places like where I am in Miami, you really got to start paying attention. You really should be paying attention throughout hurricane season because all it takes is one storm. September, the peak of the season, it's pretty busy wherever. If you're on the southeast, you're at risk. And October, you're still at risk. That warm water really just exists in that Western Caribbean, but a lot of storms can form in October. In November, it's getting pretty cool, so there's not that much. And so this is kind of a really pretty graph that shows all the storms from 1851 to near present in the Atlantic and from 1949 in the Pacific. And you can kind of see, wow, the East Coast really gets impacted. Thankfully, due to the way wind patterns are, you don't get that many in California. You get very, very few. But you can see kind of anywhere on the eastern seaboard can be impacted by hurricanes. So what are the key ingredients necessary to create a hurricane? Well, the first thing you need is some spinning wind. This spinning wind comes from storms usually off the coast of Africa. We call them African easterly waves, but they kind of start as these thunderstorms. They move off the coast and they start to get energy from the ocean. The second thing you need is a moist atmosphere. So hurricanes have a lot of rain associated with them. So you need a lot of that moisture to create that rain and that hurricane. And last, but certainly not least, is you need a deep layer of warm ocean. Again, this is what I think is the most important thing because it's what I study, but that's where that energy comes from. So what about fatalities? So if we look at the fatalities, what causes the most amount of deaths in the US? You may think maybe it's wind because that's how we base the strength of a storm. But that's not. Wind only accounts for 8% of the fatalities from 1963 to 2012. Water, on the other hand, accounts for 90%. Storm surge being half of that, and then flooding due to rain is over a quarter. That's a lot. Hurricanes can also spring off some tornadoes. It doesn't happen often, but they cause some damage. So what do I mean by storm surge? So as a hurricane comes in, it pushes a lot of water with it. This is due to the winds and the pressure. It pushes all this water and it can create a big flood. And so what this slide shows is an example of you have waves, and then as you get a stronger storm, it starts to rise up. Then it starts impacting where the the beach is and where this house is. And by category 3, this house is underwater. And by cat 4, it's gone. I mean, by category 5, there's nothing left. Everything's underwater and it's gone. And this is an example of one beach, but areas like where I am in Florida, it's super flat. So it doesn't take much. You don't need a category 4 storm to impact houses. Even a tropical storm can create a big storm surge. Also depends a lot on the shape of the beach. So what can we do to reduce the amount of deaths and damages? Well, that's by helping people prepare better in advance. And so that's through forecasts, accurate and timely forecasts. So how do we do this? Well, we use computer models, really. And so these computer models, you simulate Earth in your computer, and since it's in your computer, you can speed up time and look at where things are going to go in the future. But to simulate all of Earth in a computer, you need a pretty strong computer. NOAA's computer, as of 2018, can do 8 quadrillion calculations a second. That's a lot. To put that in perspective, if you took your 9 best friends and you, so 10 of y'all, pulled out a calculator, you just did 1 + 1 equals. Every second, you could do a calculation a second. You and your 9 best friends, so 10 people, it would take y'all over 25 million years to do what this computer can do in 1 second. So it's pretty crazy. The Europeans have a pretty similar strength computer. It can store more than 50 million movies. That's like watching HD movies nonstop for 1,500 years, a lot longer than all of us will likely be around. So they're pretty powerful computers. But we want the best models, right? These models are what we think simulated Earth. So how do we get the best simulated Earth? Well, we got to put in as much of Earth as we can. So this is in the form of data. And this data comes from a lot of places, such as satellites, like we saw the pictures from earlier in outer space, radar, or other ground observations, such as these buoys out in the ocean. We also fly planes into hurricanes, which give us a ton of data. So these are NOAA's planes. The Air Force also flies planes, and NASA has in the past. But what we see here in the background is the P3. So this is the plane that actually flies into that eye wall, into the most dangerous part of the storm, and into that eye to collect the best data. So what's it look like when you're flying a plane into a hurricane? So this is a picture inside the eye of Hurricane Irma. And so yes, it's beautiful, it's sunny, but this is a great example of if you are ever stuck in a hurricane and it gets really, really calm and it's sunny out and you walk outside and you see clouds like what you see here in this image, just a gigantic wall of clouds all around you. You're not at safety and do not go explore. You're in the eye. And while it may be calm then, you have that eye wall, which is the most dangerous part of the storm. There's this beautiful image that just shows how powerful and big the hurricane is. The other thing that's been going on a lot recently are flying these autonomous or unmanned and remote vessels. So here in the top right is a glider. This is like a submarine. Someone writes a program and it goes under the water and collects data on the ocean. Here in the bottom right is a coyote. It is a little plane drone that they drop out of the bottom of the big plane in the eye, and it actually flies around in the eye and collects a lot more data. Here in the bottom left is a new thing this year called the sail drone. So this is a pretty cool thing. My boss, my advisor, is actually the one in charge of it. But these are sailboats that are sailed by someone actually in California all over the world. They're on a computer. It's like a video game, sailing it. And we tried to sail it into a hurricane. Like I said, this is a new project this year, and we actually got one. So we made it into the eye wall of Hurricane Sam. It was a category 4. And this is what it looked like on board the video. So hopefully this plays pretty smoothly. But you can see it's rocking and rolling. That's because the waves were over 50 feet tall. That's pretty big. I think there's one wave recorded at 90 feet. The winds, category 4, that's what all that white is. That's sea spray and the rain. Just not a place you would want to be. This is pretty cool. The sail drone ended up being one of the top 10 ocean stories of 2021 in the Smithsonian, one of the top 5 stories from 2021, according to NOAA's research. So really, really cool thing. And we hope to keep sailing them into hurricanes that are out in the open ocean that don't impact people, so we can get a lot of cool data. So one of the things I wanted to end on is what you can do to help protect yourself and how can you prepare for a hurricane. So the first and most important thing is know where you are and have a plan. So know where you can evacuate, know multiple places to evacuate in case, hurricane comes at different angles, but having a plan. I always tell people, even if it's not a question of life or death, odds are there's a good chance you survive most storms, but it's a question of comfort. You can be out of water and power for weeks. That's just not fun. What do you prove by saying, I rode through it? Evacuate, go to safety, And if you can, just make it a fun vacation. Go visit friends or family that you haven't seen in a while and just evacuate. Second thing is, in the case you can evacuate, cannot, have an emergency kit. I have one. It's full of water, food that won't go bad, batteries, radio, flashlight, that type of stuff, medicine. So have one that can at least last 10 days for everyone in your household. And lastly, prepare your home. So could be putting up, shutters or cleaning up branches that are hanging over your house, etc. But when in doubt, evacuate. That is the most important thing, and follow the official resources. And before I take questions, I think it's part of my job as a scientist when talking to people is just to briefly mention climate change. It's something I can talk about for hours and weeks, but that's not the point of today's talk. But it's something important to me that I mentioned. And so all I will say is, we know it's happening. That's a fact. We also know that humans are the primary cause to it. But that being said, you guys are really important, because if you look at what can happen in the future, acting now will make a massive, massive impact into the future. So it's something definitely to care about. And with that, I'd like to take any questions. I've also thrown out my email in case you'll have any more questions.
Lev, that was great. I just learned so much about hurricanes. Thank you so much for that talk.
Awesome,
I do have a couple questions for you. Why did you become a meteorologist?
That's a great question. So I didn't even know anything about meteorology or oceanography going into high school. So I found out when I was applying to colleges. I knew I liked math and science, and I liked being out and doing hands-on stuff. And so always thought I wanted to be an engineer. And then I found out there was an elective at my high school called oceanography, and I took it. And a lot of people took it as a joke because it was the easy science to get the science credit. But I thought it was cool. Found out you could actually get a major in it, and fell in love with it and changed every application. I don't think I applied to a single school for engineering, only oceanography or marine science. Growing up surfing and water skiing, I love the water. So it was kind of the perfect match. And I grew up tracking these hurricanes because if one's staying way off the coast, it produces pretty fun waves to surf.
How big can a hurricane get?
Yeah, that's a great question. They can range in size a lot. So one of the things that hurricanes do is they move kind of up further north and get away from that really warm water. They can go through something called extratropical transition, in which they expand a lot. So storms like Sandy, they were going through that, and that's why it was such a big storm. The average size of a hurricane's about 300 miles, but you can have one like a tropical storm Marco that was only 11 miles wide, was how wide the winds were. Or you can have one like Typhoon Tip, where the winds reached over 1,300 miles wide. So it really depends. And there's not really a size to strength ratio either. You have Hurricane Wilma that was really small but really powerful. All it takes is one storm. That's the big thing, that even if I always tell people, is it going to be an active season or not? And it doesn't matter, honestly, because all it takes is one storm hitting you. And if you're in the path of the winds, it's not pretty. So
one more question. What's your favorite part of your job?
That's a great question. I think my favorite part is probably that every day is different. I do not know what to expect when I come into the office. I will say one of my favorite things is doing things like this, giving out talks. I love explaining what I do and encouraging people that it's fun and they should do it too, because we could always use more scientists. But no day's the same. I could go into the office and, a lot of what I do for my research is writing code, which to some people sounds terrible. I happen to enjoy it. But then I have friends that go out and they go diving every day or some days, and then they write code, or there's just no way to know what to expect each day. It's fun, and I get to ask questions too. So my job as a scientist is I ask a question and I go, if no one knows the answer, I look up and see, does anyone anywhere know the answer? And if not, well, why don't we find out the answer? That's pretty fun to have a job that I don't know what to expect, and I just ask questions pretty much and try to answer them. So
I agree. That's my favorite part of being a scientist too. All right. Well, thank you so much. I hope everybody reaches out to you with all their questions. And yeah, stay tuned for more. Have a great day.
Awesome. Thanks. You as well.